These are in listen-only mode.
Good morning, everyone. My name is Sue Tetzfeld, and I'd like to welcome you all to today's webinar, Navigating a New Era of Drinking Water Discharge Compliance, sponsored by BayWork. BayWork is a consortium of Bay Area water and wastewater utilities working together to ensure that we have the reliable workforce needed to serve our customers and protect the environment. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of the attendee interface. You should see a control panel in the upper right corner of your screen. You can hide your control panel at any time during the webinar by clicking on the orange arrow. The webinar will automatically default using your computer's speaker system. If you would prefer to join in over the telephone, just select telephone in the audio pane and the dial-in information will be displayed. After logging on, your microphone will automatically be muted. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and try to address as many questions as we can during a brief Q&A session in the middle of the webinar and again at the end of the presentations. Today's presentation will be recorded and will be viewable at baywork.org within the next 2 weeks. I would now like to introduce Robert Scott, the chair of the BayWorks Staff Preparedness Subcommittee, who will be the moderator for today's webinar. Good morning, Robert.
Hi, Sue, and good morning, everyone. I want to welcome you again to BayWorks webinar on the National Pollutant Discharge Elimination System, also known as NPDES. We are so glad to have our presenters, Casey Claiborne and Adam Pfeffer, with us today. Casey is a water quality engineer at San Jose Water Company. He is responsible for their Clean Water Act and their Clean Air Act environmental compliance. He has a master's degree in civil engineering from Cal Berkeley. And Adam is also a water quality engineer at San Jose Water Company. He has been leading their distribution system optimization efforts for the last several years. He has 10 years of drinking water project experience and is a professional civil engineer in California. He received his master's degree in civil and environmental engineering from Cal Poly San Luis Obispo and his bachelor's from Dartmouth College. And without any further ado, we'd like to turn this over to Casey.
There we go. Thank you, Robert, and good morning, everyone. Today I'll be talking about how to comply with the new state NPDES permit for drinking water system discharges. We'll be discussing the discharges covered by this permit, the requirements that go along with having this permit as a drinking water purveyor, and San Jose Water Company's experiences so far complying with this permit. Just a brief history of the permitting process for drinking water discharges. There was a statewide permit first proposed for adoption in 1996, but this was not adopted at that time. Here in the SF Bay Region 2 of the Water Control Boards, drinking water systems have been discharging under the MRP, the Municipal Regional Stormwater Permit, that's issued to MS4 operators. Drinking water systems that did not operate in MS4 themselves were not technically permitted, but complied with the C15 section of that MRP. The new statewide general permit was issued and adopted in November of last year. This permit covers discharges from drinking water systems to receiving waters and the storm drain. And it's broken up into rules for planned discharges and rules for emergency discharges. Now, as compared to the MRP, this new permit provides regulatory clarity. It actually covers drinking water purveyors that are not part of an MS4. And it covers the majority of drinking water system discharges, as we'll see shortly. So planned discharge activities covered under this permit include supply well blow-off, tank or reservoir releases, trench dewatering, distribution system flushing, and water treatment plant operations, among many other discharge types. However, the permit specifically excludes filter backwash discharges to receiving waters. Emergency discharge activities covered under this permit include emergency drinking water system failures and repairs, such as leaks or main breaks, such as this one. It also covers operation errors, such as a tank overflow or catastrophic events, whatever those might be. Now I'd like to hand the presentation over to Robert briefly so we can do our poll question.
All right, Casey, let me launch this poll question. And so our question is, have you received your notice of applicability from the state board? You can answer yes, no, or what is that? We see some answers coming in now, and I'll give a few more seconds to get all the answers in. But have you received your notice of applicability from the state board? Yes, no, or what is that? All right, we'll be closing the poll in a few seconds here. I still see a few answers coming in. So we'll close the poll in 5, 4, 3, 2, and 1. And let me share the results of the poll. There you go.
Thank you, Robert. So it looks like relatively few of you have not received your NOI, or you're just not sure what it is. And that's all right. So the NOI, the notice of intent, or I'm sorry, the NOA, excuse me, that's what the question was about. The NOA, the notice of applicability, is a letter received from the State Water Board in response to an application to be covered under this permit. As this is a statewide permit and most everyone that we've talked to has applied under it, it's taking a while to get to everybody, but it's good to see that a good number of you have actually received yours, so hopefully we can expect ours sooner than later. All right, let's move on here. So let's talk a little more in depth about this general permit. So this general permit requires notification when there's going to be a discharge, or there has been. It's been an urgent one. Implementation of best management practices, monitoring of certain discharges, but thankfully not all of them, record keeping, and of course reporting. Now, pre-notification is required at least 3 days in advance for any planned discharges that are exceptionally high in volume. 1 acre-foot or 325,850 gallons is the threshold. Now, if you need to conduct an urgent planned discharge, the permit requests that you inform the regional board or the MS4 operator at most 24 hours after you discover you need to conduct that discharge. Post-notification is related to an adverse effect or an impact on a receiving water. So within 24 hours of becoming aware of that impact due to either non-compliance, a system failure, or some emergency circumstance, it's the same sort of deal. Within 24 hours, you must notify the regional board and, if applicable, the local MS4. And in addition to that, there's the requirement that you provide a written report to those parties within 5 days. And this report details what that impact was, the extent of it, how it was mitigated, and what will be done in the future to prevent that sort of impact. As for best management practices, they're required at all planned discharges, as one might expect, and at emergency discharges as soon as is feasible, while concurrently protecting public health and safety. Permit also requires that water purveyors maintain a log of BMPs that are implemented for different types of discharges. Now this can take the form of field documentation, or standard operating procedures, or most likely both. Here, just as an example, we have a main break and some fine BMPs being implemented. So there's a pump down in this trench here that's discharging through a hose, through a diffuser with some dechlorination tablets, down towards the drain where we have this gravel bag dam set up to prevent suspended sediments from entering the storm drain. Now, as for monitoring under this permit is required only for planned discharges, and monitoring of every discharge as it happens is only required for what they classify as event monitoring discharges. These are set up in 3 categories. One is superchlorinated discharges. Those would be water that's been dosed with chlorine for disinfection purposes. And generally that's greater than 4 parts per million, or milligrams per liter. It also requires monitoring for every well development or rehabilitation discharge, or any large volume discharge, those discharges greater than 1 acre-foot. As for all the other discharges you conduct throughout the year, the permit requires that you conduct annual representative monitoring. So for each discharge category for which the water will have the same water source, the same water treatment, and same implemented BMPs, those discharges just need to be monitored once per year per category. Now, to clarify, in the state permit, monitoring means taking actual samples for chlorine and possibly pH. Turbidity can be either estimated visually, or you can take a grab sample and use a meter. One thing I want to emphasize with this permit is something called an effluent limitation. So exceeding this effluent limitation is a violation of the permit and will result in regulatory enforcement. For the only effluent limitation under this permit is for chlorine residual. They've set the effluent limit nominally at 0.019 milligrams per liter. However, it's essentially impossible to measure that low with field instruments, so they've set this boundary of 0.1 milligrams per liter. And field measurement that's greater than or equal to that level, that's not deemed to be a false positive, is a violation of the permit under certain conditions, and we'll get to that in a moment. Those conditions being superchlorinated discharges or planned discharges directly into or within 300 feet of a creek. So to clarify here, this column on the left indicates what discharges would be monitored under this permit, and the column on the right attempts to explain when the effluent limit applies. So for well development and rehab, this effluent limit won't apply unless for some reason the discharge is chlorinated, while for superchlorinated discharges, the effluent limit will apply in every case. So superchlorinated discharges under this permit are one of the main sources of regulatory risk, as it were. As for large volume discharges, annual representative monitoring discharges, and any other compliance samples that are collected, those will be subject to this effluent limit only if they're within 300 feet of a receiving water, or if they're being directly discharged to a receiving water. That is, not going through a storm drain or some other constructed conveyance device. This permit also has an action level for turbidity of 100 NTU. This applies to groundwater wells and discharges related to development, rehabilitation, or, as the permit states, operation discharges. So potentially any discharge from a groundwater well would need to meet this turbidity action level. And exceedance of that requires the discharger to modify, change, or enhance their BMPs. However, this permit requires sampling only during a discharge at 10 minutes and then further along in time. So if the first little burst of water out of your well is cloudier than 100 NTU, but it clears up, it's understood that will happen. And so your first sample needs to be under 100 NTU so as to not exceed the action level and therefore require further action on your part. Now, as for record keeping and reporting, this permit requires that you track the number of direct discharges to receiving water in a year that are greater than 50,000 gallons. So to that end, you need to figure out whether a discharge is a direct discharge or within 300 feet, and also what volume it is in each instance. You also need to keep track of the total volume discharged to receiving waters and the total volume directed to beneficial use, that is a groundwater recharge sump, some percolation basin, irrigation, or some other use, and the permit details what is applicable there. So in addition to that, you need to keep all of your discharge monitoring data, that is your representative monitoring, and those three categories of discharges that we mentioned before. And this annual report for the year's data is due March 1st of each year. So to conclude here, I'd like to talk a bit about San Jose Water Company's experience under this permit. Here at San Jose Water Company, we have several distinct departments, each with multiple discharge types. Three I'd like to focus on are operations, distribution services, and construction, although we have several others that for which their discharges are not as challenging to comply with this permit. In any case, BMPs were in place already, certainly as a consequence of the MRP and previous regulations, but we needed new and different paperwork and some training on account of the new permit. So to this end, we needed to advise each group in a way that was focused on their specific needs for discharge compliance. Some of the things we implemented were tailored SOP development, employee training, field support, and just being available for any questions and different circumstances that came up. And also just documenting what goes on and what our expectations are. So our operations department manages our facilities like tanks, booster pumps, and well sites. And they have two primary discharge types, one being well blow-off to waste and the other being tank draining. Those two have the highest likelihood of all our discharges of exceeding the 1 acre-foot threshold, which, to reiterate, requires monitoring of turbidity and chlorine residual if that discharge is chlorinated. So as an example, returning a groundwater well to service is sometimes difficult to predict what the total discharge volume will be. Especially when it's a high priority time-wise. Well needs to be brought online so as to supply water to your customers. It might be that well needs to be blown off for 3 or 4 hours, and that'll easily exceed the acre-foot threshold for higher capacity pumps. As for distribution services, They respond to leaks and main breaks, which are classified as emergency discharges. And as such, they have limited data collection requirements. However, for emergency discharges next to a creek, the permit requires notification to the MS4 and the regional board if an adverse impact or effect is observed. Just to be clear, the permit doesn't require that you observe every discharge to a creek that's associated with an unplanned discharge. However, if your field crews or a neighbor notices that there's an impact and notifies you, you're required to then notify the regional board. As it happens, this department also is responsible for installing some new mains, which we discovered is a process of figuring out how we're going to comply with this permit. And installing new mains involves lots of planned discharges, which do require monitoring, as is the case with our construction department. So San Jose Water's construction department manages several contractors that conduct main replacements and other capital projects. This provided an additional challenge as we had non-San Jose Water staff still operating under our permit. So they're required to abide by all the requirements of the permit, but there's just several more layers of supervision and communication that have to be filtered through in interpreting this permit and just providing them with guidance on how to comply. So here we have some of our contractors in the field conducting, in this case, a superchlorinated discharge flushing a new main. And these construction discharges provide some of the most challenging discharges from a regulatory standpoint, in that they're either highly turbid or in some cases superchlorinated, as with tie-ins and flushing new mains, respectively. So to this end, more extra work, rather, needs to be put in terms of implementing BMPs and also just supervising and ensuring that those discharges are managed properly. We have other departments here at San Jose Water that all discharge water from time to time. However, these discharges are, in nearly every case, very low impact. And under this permit, thankfully, though there isn't much in the way of requirements to ensure compliance with for those discharges. That's because these discharges are generally low volume and of ordinary drinking water quality. So as long as you've developed BMPs that are appropriate to those discharges, such as discharging to percolation basin or even passive dechlorination if the volume and the flow rate are low enough, are entirely appropriate. Often these discharges never reach surface waters, and in those cases these are often covered under beneficial reuse provisions in this permit. So here at San Jose Water, we're still working to ensure that this permit is followed to the letter and that we have no violations, which is an important goal for any organization. To that end, we're still refining our BMPs and our SOPs. We're working on electronic data management so that we can more efficiently handle the administrative responsibilities of complying with the permit. And we're assessing the need for any additional training that might be required. Additionally, we're happy to collaborate further with other drinking water purveyors, and to that end, I'd like to open things up for a question and answer session.
Thanks, Casey. There's no questions at this time, but someone did note that it's good to know where the 0.1 limit comes from. And I just got another question. Here it is. If you have had an adverse impact that required notification, what, where, and they. I don't know if that's completely
I think he was saying, what were they?
What were they? Okay, thank you,
The
Sue.
adverse impacts, no problem.
Yes, he said if you had adverse impacts that required notification, what were they?
Thank you both. So thankfully, under this permit, we haven't observed any adverse impacts for some larger main breaks next to a creek or, let's see, and I think those are actually the only I'm sorry, we had a tank overflow as well. So in all those cases, we observed that downstream of that site, the creek was essentially dry. So all of that water percolated in before it got to any fish or other organisms that might be impacted by the undechlorinated chlorinated water, if that makes sense.
All right. There's another question here, Casey.
Oh, I'm sorry. Go ahead.
What is the time frame for recording, monitoring, and sampling high turbidity characteristics in water discharges?
Sure. So the permit does a good job of spelling out many of these details, but for the timeline for sampling, it's required to sample sometime in the first 10 minutes of the discharge. If it lasts longer than 10 minutes, it's required to sample at 10 minutes and at an hour if it lasts that long, or just at the end of the discharge if it doesn't. And if it lasts more than an hour, then you're required to take 3 samples, and this goes for chlorine, turbidity, and pH, which is just for superchlorinated discharges. So for that instance where it lasts longer than an hour, samples would be taken at 10 minutes, at an hour, and then whenever the discharge is finished.
Okay. I'll take one more question now, and then we'll move on to Adam. And this question actually may be better suited for Adam, but you guys can determine that. But the question is, does San Jose Water Company utilize any equipment or BMP to mitigate an unplanned discharge from distribution storage tanks, for example, tank overflow due to overpumping?
That's a great question, and that's a great segue to my presentation. So I think I'll go ahead and talk about our BMP for tank overflows, and as part of the presentation, and if there's follow-up questions, I'll take those at the end.
Sounds like a good plan. So for that purpose, I'll go ahead and pass the presentation over to Adam. Take it away, Adam.
All right, thanks everybody for attending. I'm going to be talking about a new emergency overflow dechlorination strategy, specifically regarding accidental tank overflows. And as Casey mentioned, there's a lot of liability utilities have when looking at chlorinated water discharges, and so I would like to talk a little bit about bringing awareness to what some of that liability is, and explain the challenges in addressing some of those liabilities, and then share our solution to one aspect of the problem, and talk about some of the test results and conclusions that we have from implementing it. So what the basic concept of the risk is that we use, as water purveyors, we use a disinfectant residual in potable water that's generally chlorine or chloramine, and that residual protects the drinking water against any bacterial intrusion or compromise of the integrity of your system. But it's also toxic to fish and other wildlife. So if this chlorine and chloramine can get into natural waterways, you can cause damage. And in addition to the damage to the environment, there's damage to your finances as well. There are mandatory minimum penalties from the Water Board for chlorinated water discharges. So when this happens, there are consequences, and this is an example. This is just a news story that you can find online. It was a record $3 million fine proposed by the Water Board against a San Jose water company. The bummer about this is this wasn't us. It's in the papers, and just goes to show that discharges happen. We actually followed up with AP, I think, and they said, well, it was a San Jose water company, so the headline's okay. So we got all the phone calls and stuff. But this does happen to water utilities, and the more it happens, the more utilities are expected to be proactive in protecting against damage to the environment. So, people make mistakes, but if you make the same mistake twice, there's a little less forgiveness involved the second time. So there's this expectation on utilities to try and think ahead and plan how can you mitigate the effects of a potable water discharge. And if you're looking at something like a tank overflow, the problem with dechlorination systems is you can't really know the volume or the rate of an unplanned discharge from something like a tank overflow. They're usually unplanned by definition. So you can't really feed a liquid chemical like sodium bisulfate or sodium thiosulfate to try and dechlorinate whatever water is being discharged if you don't know what that volume or that rate is going to be. And if you overfeed those type of chemicals, you can cause damage to the environment. They have an impact on oxygen in the water, and there are instances of utilities being fined for having creating damage to the environment by overfeeding dichlorochemical and sucking all the oxygen out. So you have to be very careful with that. And the electrical systems for these feed pumps need a lot of calibration and PM, and it's just a high-risk proposition to count on one of these systems to work properly in the event of something that you hope will never happen. One way to get around the pumping problem is if you have a saturation system where you have some kind of tablet or granule that dissolves into water, especially if it's vitamin C, then it's not harmful to the environment, so your dosing is not as much of a concern. The problem with vitamin C is these tablets degrade very quickly at atmosphere, and they're expensive to replace. So if you're not really on the ball at changing out your vitamin C tablets, they're not going to do anything for you when that overflow happens. So to specifically address the problem of tank overflows, we've been working with TideFlex, Red Valve company, to create a stable, dry atmosphere to extend tablet life that can be installed in line with existing tank overflows. Here's just a kind of conceptual drawing of a tank with an interior overflow. It comes out, and then in line we have this device or assembly, and I'm going to explain that here. So here's a schematic of it. You can see the dual ductile valves creating a somewhat hermetically sealed chamber in here to preserve the integrity of the tablets over time. There's a screen cylinder in the flow path that holds 25 cylinder tablets, at least this model does. There's a cam-locked chamber access to pull this cylinder out and reinstall tablets, both preventatively and after a discharge. And there's a blending trough underneath the cylinder so that the water comes through and has a chance to flow around and interact and have contact with chemical for dechlorination. And then lastly, there's an air gap, which is required under the Waterworks standards for California for your tank overflows. So here's a pilot testing of the first dechlorination assembly that was produced. It's at our operations center in San Jose. We have a setup here with two 2.5-inch fire hoses and one 4-inch hose coming from a fire hydrant and going to the top of this standpipe here. We have inline flow meters. They're not in the picture over here, but each of the hoses has an inline flow meter, so we could totalize the flow as it's going to and figure out how much we're testing. The hoses are braced on the top of the forklift so that they don't come loose and hit someone's car. And we have this 8-foot standpipe that's attached to get the hydraulic head pushing through the valves. The water coming from that fire hydrant, which is hiding behind my other presenter, Casey, there. And we have these meter boxes to support the assembly for testing, and a sample collection port that we knocked out right there. And then there's the diligent scientists taking the field data, doing our DPD tests for total and free chlorine. So our test approach was to try and simulate a tank discharge and measure the effective time we got dechlorination until that chlorine started coming through as a breakthrough. We used a chlorinated water source, it was groundwater from our system. We tried to maximize the flow as much as we could. We monitored every 5 minutes. And we tested both fast and slow dissolve tabs. When I talk about the results in a second, I'm going to focus on the slow dissolve tabs. We primarily tested the fast dissolves in case the slow dissolves couldn't keep up with the discharge flows, and the fast dissolves were necessary in order to achieve complete dechlorination. But it turns out that wasn't the case. The slow dissolves did just fine. So I'm not going to talk much about the fast dissolve data. And then we tested at 3 different flow rates to extrapolate what kind of performance we could expect at higher flows. And we did a control test to see what kind of removal dechlorination happened when we were running the system without any dechlor tablets in it. So here's some videos I have from our test setup. This is me turning the hydrant on, getting the flow through the hoses. You can see the meters as we pass by. And in this instance, the flow did get up to 1700 GPM. You can see there's a little hand floating down by the sample port where we took the water samples. And we'll zoom in a little bit, and you can kind of see that high flow going into a DI. Oops. And here's the other video that I have of me taking a sample, doing a little triple rinse on our sample vessel, and pulling the sample out and taking it over to the data table for analysis. So here's the data from our testing. These lines up here show the periodic testing we did of the chlorinated level of the source water. So you can see when we first started, we had to flush a little bit before we got to the true residual in the system, but for the most part, they're pretty close to between 0.6 and 0.9 throughout the duration of the testing. And we did these 2 runs here, and the effluent residual stayed low in both cases for an hour and 10 minutes until breakthrough. So we had a consistent time to breakthrough over the 2 runs. And as Casey mentioned, this may look a little noisy, but it's very difficult to measure chlorine in the field below 0.1 ppm, so this is really effectively 0. We did this is the data from our control test where we tried to check and see how much dechlorination was being achieved just by the assembly without any tablets in it. So running at 3 different flow rates. At the lower flow rates, you get very little to none chlorine removal, but at the highest flow rate, just the aeration, I guess, from going through the assembly did provide about a 30% chlorine removal. But in that case, we're talking about going from a 0.9 to a 0.6. That's not going to get you very far in terms of your creating a safe discharge without harming the environment. And at our flow, 3 different flow rates, what we did is we looked at the rate of chlorine usage by mass per minute of discharge at the 3 different flow rates, and then created a trend to try and show what the life or breakthrough we could expect to see at higher flows. And this is the trend we came up with. 3 data points is not great for a trend, so I wouldn't take this to the bank, but it gives you some sense of maybe if we up the flow rate to 2,500 gallons that we maybe could expect to see something in the neighborhood of 40 minutes until breakthrough, somewhere along those. So it's a rough guideline for projecting out for at least this device. We have been talking to TideFlex about doing productions for other scale discharges, and we've been talking specifically about one instance where we're working towards a model that would work for a 10,000 GPM discharge. So this curve wouldn't really apply to that. So what we know is that with this assembly, we can rely on about 70 minutes of dechlorination at 1700 GPM, according to the data that we have. We can change out tablets less frequently than we otherwise would. With these slow dissolves, they have a shelf life of 3 years. I'm hoping we can manage annual changeovers for the tablets when they're in the sealed chambers. We do have some desiccant that has a color change indicator that should help us figure out when we need to change out the tablets. And our next steps, we do need to do some testing for chloramine removal, see if it works just as well with chlorine as it does with free chloramine as it does with free chlorine. We are going to set up some in situ testing after this is installed, see if we can test some higher flow rates through this device. And we're going to try and test, make sure this concept scales up so that we can do higher flows like the 10,000 GPM that I was just mentioning. And that's all I have. So at this time, if there's any other questions for me or Casey, we can take them now.
All right, we want to encourage you to type any of your questions into the question pane, and we'll have time to answer those. But while we're doing that, I do want to find out from all of our attendees about your system that you may be using. So here's a polling question that we'd like to ask you, and I'm going to launch it now. And our question is, what does your agency mostly use to prevent against accidental overflows at reservoirs? Float valves, proximity switches, dechlor tabs, other method, or you don't know? So if you guys could please answer that question. What does your agency mostly use to prevent against accidental overflows at reservoirs? Float valves, proximity switches, dechlor tablet bags, other method, or you don't know? Okay. All right. I see answers coming in here, and we'll close the poll in 5, 4, 3, 2, and 1. I'll share the results.
That's interesting. It looks like the majority use a different method that's not listed there, and float valves are pretty popular as well. I think we use float valves in conjunction with this intended installation. So it's a good approach to use multiple barriers here.
Okay, I do have a question now, Adam. What brand tablets do you find most effective for long-term use in the chamber?
Well, I will say, this data is fairly new, so we don't have a lot of experience with different tablets at the moment. We've been using Vita Dechlor, and the slow dissolves have better longevity than the fast dissolve, but we've yet to do brand comparison with a product.
Okay. All right, we do have some time remaining, so if you have any additional questions, feel free to ask them. And we do want to remind you that we will be posting the webinar as well as the PowerPoints on the BayWork website within 2 weeks after today. And we want to invite you all to visit our website. So, don't see any other questions at this time. So therefore, I want to thank you, Casey and Adam, for presenting such great information and sharing your great experience with us. And I want to thank all of you for joining us today. We want all of you to please stay tuned for other Baywork events and invite you to visit our website at baywork.org. Also, please know that the recording of this webinar will be posted at baywork.org within the next 2 weeks, as I said earlier. And additionally, we will email contact hour certificates to those who answered yes to the questions regarding them on the registration form. Lastly, we really want to know your thoughts about this webinar. Please take a moment to complete the survey you will receive immediately after we're done. It's only 3 questions. And well, we have another question here, Adam and Casey. The question is Tide Flex making this system available commercially for sale?
Yes, they are. And they're branded as the DOSA, D-O-S-A.
All right. Great. Well, at this time, Casey or Adam, do you guys have any final words or comments?
Thanks, Robert, for hosting.
Yes, thank you, everyone.
All right. With that said, again, we appreciate your attendance today. And on behalf of Baywork, thanks again for joining us. And please have a great rest of the day and rest of the week. Until next time, goodbye, everyone.